All right, today we're going to work with imaginary numbers again, and we're going to focus especially on the idea of complex conjugates. But before we do that, I want to review something with you. Our old friend, the difference of two squares. If I multiply 5 plus 2x times 5 minus 2x, we learned a shortcut for that we call the difference of two squares. And we don't have to do FOIL. We can just square the 5, make it 25, square the 2x, make it 4x squared, and put a minus between them. It's called the difference of two squares. Well, that can happen as well when we're dealing with what's called complex conjugates. Been working with imaginary numbers with our old friend I, and complex conjugates are essentially the same setup as a difference of two squares. Well, they are the same setup. A plus bi times a minus bi. So if I use our difference of two squares shortcut, this is a squared minus b squared I squared. And we know that I squared is negative 1. So that makes this a squared plus b squared. The I disappears, which can be handy sometimes. All right? So, for example, if I had 5 plus 2i, let's say that was my complex number, and they ask you what is the complex conjugate of 5 plus 2i, it's 5 minus 2i. All right? This is called the conjugate of that. And the reason is what I just explained to you. When I multiply those two together, the I disappears. All right? So they're going to give you some problems tonight in homework where they say, write the conjugate. Write the conjugate and then multiply by it. Should be pretty straightforward. Shouldn't be anything tricky about that. If they give you, let's say they give you the complex number 4 plus 3i. And they say, write the conjugate and then multiply by it. Well, as far as I'm concerned, you can just write the problem down and then start working. The conjugate of 4 plus 3i is 4 minus 3i. Okay, 4 minus 3i is the conjugate. And I know from what I just showed you that when I multiply these two, I get 16 minus 9i squared. The I disappears, and the answer is 25, because I squared is negative 1. Okay, I squared is negative 1. Now, that one's pretty obvious. This one works the same way, it's just maybe a little bit uglier in the way it's written. Negative 2 minus the square root of 7i is still a complex number, it's just not as pretty. So my conjugate of that would be negative 2 plus the square root of 7i. And then we just use our difference of two squares shortcut. Negative 2 times negative 2 is 4. Minus square root of 7 times square root of 7 is 7. I squared. I squared is negative 1, so the answer here is 11. All right. Now, they could also ask you to do the same thing and just give you this. they could say write the conjugate and then multiply by it. And you might be thinking, well, what's the conjugate? Well, let's clean this up first. Let's take our I out and then make this the square root of 16 times the square root of 2. So this is 4 square roots of 2i. Well, you might be thinking, what is the conjugate of that? Well, this is like, you could think of it as 0 plus 4 square roots of 2i, right? So the conjugate would be 0 minus. So what I would do, if they give you a problem like this, is all you really need to do is multiply this by the negative 4 square roots of 2i. That will be the conjugate. All right? So it's going to be negative 16 times 2 times I squared. So that's going to be negative 32 times negative 1. It's going to be positive 32. All right? Now, there's a couple other things that they're going to ask you to do, and these next problems really tell you why we're doing this. The reason we need to learn this technique is because we don't like having an I in the denominator. So if they tell you to write the quotient in standard form, and they give you a fraction like this, 5 over 3 plus 2i. Well, remember, I is the square root of negative 1. We don't like having that in the denominator, so we're going to, you know how we used to rationalize the denominator? It's kind of the same idea, but what we're going to do is we're going to multiply the top and bottom by the conjugate. And doing that is going to get rid of the I in the denominator, in the bottom. Because the bottom is going to become 9 minus 4i squared, which we know is 13. All right? And the top, you can just do distributive property in this case. So that would be 15 minus 10i. So 15 minus 10i over 13 is an okay answer, but we typically don't leave it all over 13 if we're writing a complex number. It'd be better to split it into two fractions and make it 15 thirteenths minus 10 thirteenths I, like that. All right, now, there could be a time where when you multiply by this conjugate, I just want to make you aware of this. If they give you a problem like this, 2 plus 3i over 4 minus 2i, our process is the same. We're still going to multiply by the conjugate of the denominator, 4 plus 2i over 4 plus 2i, but notice on top here, on the top you have to do FOIL. And we did that in our last couple days working with imaginary numbers. The bottom is just going to be 16 minus 4i squared, but the top we have to do FOIL. 2 times 4 is 8 plus 4i plus 12i plus 6i squared on top. And we can clean that up. The bottom is just going to be 20. The top, I'm going to have an 8 minus 6, which is going to be 2 plus 16i. And notice again, we can split that up into two fractions and make this 2/20 plus 16/20 I. And if we're really good pre-calculus students, and we are, we would reduce those fractions and make it 1/10 plus 4/5 I. All right. One last type of problem before we wrap up, and that is adding. You may be asked to add or subtract two fractions that have a complex number in the denominator. Something like this. If you're asked to add those two, we always have to have a common denominator. And how convenient that the two denominators are conjugates of each other. It's kind of convenient. So we're going to multiply the first one by 3 minus I over 3 minus I. We're going to multiply the second one by 3 plus I over 3 plus I. All right, so we're just, it's really the same thing we've been doing, it's just kind of a different package. All right, and so the bottom, our denominator here is a difference of two squares. That's going to be 9 minus I squared, which is 10. On top, we've got to do distributive property in both cases, 15 minus 5i plus 21 plus 7i. I have to do distributive property over there as well. And so 15 plus 21 is 36 plus 2i over 10. And like we said, we normally split that up. Make it 36 tenths plus 2 tenths I, which is 18 fifths plus 1/5 I. Just cleaning up our fractions. And we will stop there for today.